Compound interest yields considerably higher interest than simple interest does because the investor is earning interest on the interest. With compound interest, the interest earned for a period is reinvested or added to the previous principal before the next calculation, or compounding. The previous principal plus the interest then becomes the new principal for the next period. In business, another common way of calculating interest is by using a method known as compounding, or compound interest, in which the interest calculation is applied a number of times during the term of the loan or investment. In this presentation, you learn to calculate the compound amount, future value, of an investment at compound interest when the present amount, present value, is known. You also learn to calculate the present value that must be deposited now at compound interest to yield a known future amount. Compound amount, or future value, known as FV, is the total amount of principal and accumulated interest at the end of a loan or an investment. Present amount, or present value, as symbolized by PV, is an amount of money that must be deposited today at compound interest to provide a specified lump sum of money in the future. Compounding divides the time of the loan or an investment into compounding periods, or simply periods. To manually calculate the compound amount or future value of an investment, we must compound or calculate the interest as many times as there are compounding periods at the interest rate per period. For example, if an investment made for 5 years at 6% compounded annually, that's once a year, would have 5 compounding periods, 5 years times 1 period per year, each at 6%. If the same investment was compounded semi-annually, or 2 times per year, there would be 10 compounding periods, 5 years times 2 periods per year, each at 3%, which is 6% annual rate divided by 2 periods per year. The amount of compound interest is calculated by subtracting the principal from the compound amount. So, compound interest equals the compound amount minus principal. Kate invested $20,000 in a passbook savings account at 5% interest compounded annually for 2 years. Let's manually calculate the compound amount of the investment and the total amount of compound interest Katie earned. To solve this compound interest problem manually, we must apply the same simple interest formula twice because there are 2 compounding periods, 2 years with 1 period per year. Note how the interest from the first period is reinvested or added to the original principal to earn interest in the second period, as you see in the solution strategy here. Ultimately, this gives us $2,050 in compound interest earned. In describing investments and loans, the advertised or stated interest rate is known as the annual or nominal rate. It is also the rate used to calculate the compound interest. Consider, however, what happens to an investment of $100 at 12% nominal interest. The greater the number of corresponding periods per year, the higher amount of interest is earned. Although the nominal interest rate is 12%, with monthly compounding, $100 earns more than 12%. This is why many investment offers today advertise daily or continuous compounding. How much are these investments really earning? The annual percentage yield, or APY, or effective rate, reflects the real rate of return on an investment. APY is calculated by finding the total compounded interest earned in 1 year and dividing by the principal. Note, this is actually the simple interest formula solved for R. R equals I divided by PT, where T is equal to 1. So your annual percentage, or APY, is equal to the total compound interest earned in 1 year divided by the principal. If your calculator has an exponential function key, yx, you can calculate the compound amount of an investment by using the compound interest formula here. The compound interest formula states A equals P, 1 plus I to the nth power, where A is the compound amount, P is principal, I is the interest rate per period expressed as a decimal, and N is the total corresponding periods. That's years times the period per year. To solve the compound interest formula, follow these 3 steps. Step 1. Add the 1 and the interest rate per period I. Step 2. Raise the sum from step 1 to the nth number of corresponding periods power by using the yx key on your calculator. And then step 3, multiply the principal, or P, by the answer from step 2. So let's use the compound interest formula to calculate the compound amount of $5,000 invested at 10% interest, compounded semi-annually for 3 years. In this case, A equals P, 1 plus I to the nth degree. So we have $5,000 as our P value, and we add 1 plus 0.05 to the 6th degree. That gives us 5,000 times 1.05 to the 6th degree. That means A equals 5,000 times 1.3400956. This ultimately equals $6,700.48. You can also follow this calculator sequence if you have the YX key. We've learned how to find future value when the present value was known. Let's take a look at the reverse situation, also commonly found in business. When a future value, an amount needed in the future, is known, the present value is the amount that must be invested today to accumulate with compound interest to future value. For example, if a corporation wants $100,000 in 5 years, where the future value is known, to replace its fleet of trucks, the amount must be invested today, present value, currently unknown, at 8% compounded quarterly to achieve this goal. Let's take a look. If your calculator has the exponential function key yx, you can calculate the present value of an investment by using the present value formula. The present value formula states where PV equals A divided by 1 plus I to the nth degree, where PV equals present value, A is your compound amount, I is the interest rate per period expressed as a decimal, and N equals the corresponding periods. That's years times the period per year. To solve the present value formula, follow these steps. Step 1. Add 1 to the interest rate per period I. Step 2. Raise the sum from step 1 to the nth power by using the YX key on your calculator. Step 3. Divide the compound amount A by the answer from step 2. Use the present value formula we just discussed to calculate the present value of $3,000 if the interest rate is 8% compounded quarterly for 6 years. This problem is solved by substituting the initial investment information into the present value formula. It is important to solve the formula using the sequence of steps outlined. Note that the rate per period I is 2%. That's 8% divided by 4 periods per year. The total number of periods is the exponent N is 24, 6 years times 4 periods per year. Let's take a look. We're going to use the present value formula A over 1 plus I to the nth degree. That means we have 3,000 over 1 plus 0.02 to the 24th degree. That ultimately gets us to $3,000 over 1.608437249, which equals $1,865.16. You can also follow this calculator sequence to get the same result.